Okay, this is problem 2.14. Page 59 in Sears. Well, it's, yeah, in a university physics book. So what do we have? We have a race car starts from rest and travels east along a straight and level track. For the first 5 seconds of the car's motion, the eastward component of the car's velocity is given by v sub x of t equals 0.860 meters per second cubed times t squared. What is the acceleration of the car when v sub x equals 12? So what we have, it's a one-dimensional problem because it's just moving east on a level ground, so it's a one-dimensional problem. And you know, t equals 0, the velocity is equal to 0. How do I know that? Because if I look at the equation, v sub x of t is 0.860 meters per second cubed times t squared. So if I put t equals 0 in, I'll get 0 times a constant, which is 0. So at t equals 0, we know that v sub x equals 0. So the question is, what is the, well, first you've got to figure out what time the car is going 12 meters per second, and then you can use that time to calculate the acceleration by taking the derivative of the velocity to find the acceleration. So make sure I'm not getting ahead of myself here. So we're okay. So the acceleration in the x direction as a function of time is the derivative with respect to time of the velocity in the x direction. And we've got a simple polynomial here, so it's easy to calculate the acceleration as a function of time. So we take the derivative of t squared, which is 2t. So 2t times this, 2 times that is going to be 1.72. And I've only got 3 significant figures here, so I'm going to leave it at that. The units are still meters per second cubed for the constant, and then we multiply by t. So 2 times that is that, if I did my math in my head right. And you can see it works out unit-wise, because if I have units of seconds, I'll get seconds squared divided by seconds cubed, which will just be 1 over seconds. So I get meters per second, which is the correct units for velocity. Down here with acceleration, I have t in units of seconds. I multiply by meters per second squared cubed, and I'll get meters per second squared, which is the correct units for acceleration. So all I really have to do is figure out what is the time. What time does v sub x of t equal 12 meters per second squared? Meters per second, not meters per second squared. Okay, so I just put 12 on the left-hand side, 12 meters per second, and they probably say 12.0 because they want to keep 3 significant figures. So you get 12.0 is equal to 0.860 meters per second cubed times t squared. So you can solve for t squared. It's going to be 12 divided by 0.86. And then get my calculator. 12 divided by 0.86 is 13.95. So since we're doing 3 significant figures, we can round it off to 14.0. And the units are going to be seconds squared, has to be, but if you divide by meters per second by meters per second cubed, you get seconds squared. Okay, so then we take the square root. We only take the positive square root because we don't have time machines, so we're not going back in time. So you take the square root of 14, which is time is 3.74 seconds. So that's the time it takes to go to 12 meters per second, and then all you have to do is find the acceleration by plugging in that time. So the acceleration in the x direction at 3.74 seconds is just 1.72 meters per second cubed times 3.74 seconds. And I get 6.44 meters per second squared. And that's what we were looking for. So we had to use calculus to come up with the mathematical relationship between time and acceleration. Took the given velocity, found out what the time was associated with that velocity, then use that time in the expression for a sub x. I'll just say to stop recording here.